Hello and greetings to all. It's been a little while since I put out a video, but I have been busy doing some work on these, and I also kind of got sidetracked by Chat GPT. It's not bad at making a Zen koan about chatbots. So at that point I had to get away from it. But as I said, I have been doing some other work. So what we'll demonstrate here today is two types of window motor. And this is the first one. And this is what I would call my pilot window motor. And I have spun this thing, using power. And it runs. And so what's it doing? When you pulse it with the correct timing with commutation, a magnet comes in there. It gets pushed out there. At the same time, there's another magnet down there, gets pushed out the other way, and so it'll spin like that. Now, this is not a great iteration of a window motor. And why is that? It's because all of this and this aren't doing a darn thing, are they? Your motive force is only coming from here and here. So to make a better window motor, what you would do is you would have this rotor go all the way like that and a line of magnets all the way like that. You'd probably want to use square magnets so that there's a good magnetic flux path and you're not getting any kind of gap there, which will mess up your field. So that would, then you would have, for a given amount of wire, a lot more of it generating motive force. But I'll tell you, I put my hand on this thing and it generates some power. So this is the first one. If we get a chance, I will spin this one. Here is the circuit for that. And let's talk a little bit more about this. So let's say you have power flowing into this coil and it's flowing this way through the coil. When it gets down here, it's flowing that way, 180 degrees different. So if this is a north facing upward magnet, it pushes it that way, counterclockwise rotation. You don't want another north facing magnet down there because the current's going 180 degrees opposite what it's doing there. So if that's north facing out, then you want this one to be south facing out, and then they're both on the same team, and they're both pulling in the same way. So if this is north and that's south, let's say you got rid of those magnets there, and it comes around, and if you pulsed it the same way, now it's a south here, so the first time we want to spin this way, but then the south would come up and it would want to go back the other way. So what you need to do is you need to, the next pulse, you need to reverse the direction that the current is flowing through the coil. So the first pulse, this is north, this is south, pushes it that way. Now just pretend these two aren't here. Now that south one comes up here, and now you switch the coil direction. And now it again, well, I mean, it would have been going, but you get the idea. It will, again, want to push it in the same direction. So with this one, you want either 2 magnets or 6 magnets or 10 magnets. I suppose, again, let's pretend these 2 magnets are gone. You could pulse it once, not do anything until the first magnet came by, and then pulse it again. And that would be monopole commutation. But in order to actually get motive power from each of the magnets swinging past, you have to do bipolar commutation because you have to have a north on one end and a south on the other. So if you have 2, you have north-south. If you have 4, you have north, south, and you need a north there, but this one's already north. So you can't have 4 because you're going to end up north, north, south, south. There's no way to do it. But you can have 6 north, south, north, south, north. Now it works, and that's what this is. And you could have 10. So 2, 6, 10, 14, like that. And it spins when you hook it up to the circuit. So all I've done so far is just spin this thing, and I'm going to begin gathering lots of data, I hope, with it. And I'm also going to wind a second coil with thinner wire and whatnot. But what I'll say is I was thinking about it, and I won't say that this is like, you know, oh, I'm trying to improve it. I was just kind of cheap. And I'm thinking, you know, when I go to build one of these that's bigger, you know, I'm going to need to buy square magnets. They're going to need to be strong. I'm going to need a lot of them. It'll be like 15, maybe 20 bucks for each magnet. So 6. And then I'm going to want to have a line of at least like 4 or 5. So like 30 magnets and 20 bucks each or 15 bucks each. So I mean, you're looking at, you know, like $400 worth of magnets, and then, you know, another $50, maybe 25 worth of wire. But you know, I'm thinking that's, you know, is there anything else I can do meanwhile to make use of this? And I started to think about this, and I thought, what if you flip the magnet like that? Each of the magnets like that. What's that going to do? And so let me just show you I'll bring up the Tinkercad. So here's the Tinkercad for that rotor. So you see you got the magnets like that. However, what if you did this? You flip the magnets on the side like that. So now you have a north facing there and south facing there. You put the magnets in there like that. So now you have a rotor that looks like this. Just as a last aside, the one thing that I would change with what I'm doing here is these bearings have iron ball bearings that are ferromagnetic, and I'll probably buy some ceramic bearings, because you want to get rid of all of the iron. You know, granted, it's not real close. I don't know if it will, but it'd be better to use ceramic. But that's may or may not be a big deal. Hopefully it won't be a big deal. So now you have something like this. So what do you want to do now? Now you want to run a coil like that. And when you do that, you have something that looks like this. Now you see it's still a window motor, but it's variation. And I'm going to call this the Mar motor. Okay, so what are the differences here? Now, if we go back to the other motor, there are 2 or 3 big differences, and I don't know how this one will behave in comparison with the other. If we go back to this configuration of the magnets and whatnot, you have the north facing up here and the south facing down there. But the other end of this magnet isn't doing anything, is it? It's just sitting out there in space. So you got, you know, this north, and the south is just sitting down there. And on the other one, it's south down, and the north is just sitting there. They're not doing anything. Here, you have your north facing. Let's say that this is north facing up. It's being pushed, let's say this way, by the wire. Now you go down here, and again, the wire is 180 degrees. The current's going 180 degrees different direction. So you want a south facing magnet. You already have a south facing magnet. It's the other side of the magnet. So potentially for a given mass of magnets, this makes it's twice as good. It makes full use of both sides of the magnet. That's the first thing. And just as another aside, you can notice that the coils are different. This one, I used thicker green wire, and there's a little bit more of an air gap there. This one, I used thinner wire, and like down on the bottom there, there's, you can't really see it, but on the bottom, there's really not much of an air gap. I mean, we got maybe a 1/4 inch. I don't know where the thing runs best. Maybe you want like a 1-inch air gap. But when we start using this coil, which is your drive coil, also as a generator coil, in other words, hooking up a bridge rectifier and pulling the inductive spike off, I want to see whether it slows the rotor down. And so even with the conventional, like a coil of wire here, going against a magnet like that, you can get away with that if the coil doesn't have a lot of induction. But when you start adding induction and bringing the coil in, you start getting Lenz's law, and the coil starts slowing down and clogging. And a window motor is supposed to be resistant to that. And so I wanted a high induction coil, which we have here. And I wanted it close into the magnets so that when we start putting a load on this thing, seeing whether it changes the behavior of this. So this thing's pretty cool, don't you think? I like it. It's also, it's kind of easier to build. It just kind of comes together better. And from what I can gather, it looks like you're also still going to want the 22-degree offset when you're running in attraction mode, although you'd want it top dead center if you're running in repulsion mode. And it's kind of hard to see that with this one, just the little bit that I was spinning, because you're kind of trying to hold the reed switch, where should it go? Whereas here, the reed switch is on the ground, and you'll just move it and you'll see, oh, okay, there's 22 degrees offset. I haven't spun this one yet. All I've done is I've put just a constant voltage into here, and I was holding the thing up, and I could see it makes it want to move around. So I think this will work. And then, is there a reason why this wouldn't work better? I mean, maybe you need more space between there and there. I mean, look at how much space you have there. Maybe it will step on its toes that way. You can get around that, but if that's not an issue, then you're making use of both sides of the magnet now. Whereas with the conventional setup, you're only making use of one side of the magnet. The other thing that's neat about this, remember we were talking before about how you need bipolar commutation with this, because that's going that way north, it's going that way south. And so you need north-south, north-south, so you need bipolar commutation as it spins around. With this, your north-south is north-south. So I can't recall, I'd have to check whether this, let's say this is north-facing, I could check, but they're all facing the same way. And the reason for that is that your north-south is now, north-south here. So north, south there, and you go to the other side, this is still going in the same direction. So if this one's facing north, you want this one facing north. And north, and then it gets the south there. So now you can use monopolar commutation. So these are all facing, let's say, all north up. Now, you could run bipolar commutation. Couldn't with 4 magnets here, because north, it has to be north, north. Wait a minute. Yeah, you could with 4. Never mind. North, north, south, south. So you go boom, north, north, then south, south. So now you can do it with 4, but you can't do it with 6, because you would have, if you had 6, it would be, you'd have to be north, north, south, south, north, north, but then you got north-north where you started. So now it's 2, 4, 8, 12, where with the other, it's 2, 6, 10, 14. Okay, it's neither here nor there, but just how this works out. So I think I showed the circuit for the bipolar commutation, and then here's the circuit for bipolar commutation where you're pulsing it off of a cap. Then here's the circuit for monopolar commutation. See how simple? Nothing to it. So in other words, power comes in here, you put your one end of your coil there, that switch closes, the other switch closes, power flows through the coil back to ground. Then the magnet comes away from the reed switch, and both those switches open, and there's no longer a connection to the positive or negative of your power source. So one dual channel SSR, and that's all you need. And then here is your bridge rectifier, where you'll gather stuff off. I should have trimmed these down, but you got so much space on the board now. I mean, I'll just leave it how it is. And then that's where you'll gather the inductive spike, the radiant. And as I said, this has a lot of induction, so it'll be curious what happens with the radiant and the behavior of the coil as it spins. And it'll also be curious whether the thing is going to work well. So, I don't think I'll have too much time to gather too much data with this video. What I'll probably do is just spin them both so you can see that they spin, and then what I'll be working on through the rest of this week is trying to get a feel for the behavior of the two. So again, you could run this as a bipolar commutated circuit and going north-south, north-south, but you don't need to, and I'm not sure it would be any better. And that's how easy the circuit is when it's monopolar commutation. And the last thing, just as an aside, I think what I'm going to do, I think I'm going to take a potentiometer, and I'm going to gather the radiant looking at loads of different resistance, because it occurred to me there might be a particular resistance that is best. Actually, I was looking at the little that's available of some of Bedini's notes, and in one of those machines he was showing the behavior pulling off the radiant with a different type of motor. This looks a little bit like there's a little, I mean, it's not at all an Adams motor. I mean, but the way those magnets are set up that way is kind of like an Adams motor. I think it was like the G-force or whatever, but he was looking at it with different resistances. So there might be an optimal resistance for your load as well. So that's yet another thing I'm going to look at. Which one should we spin first? Why don't we spin the green one? And okay, the other thing is I also need to print another one of these scaffoldings, and I'll wind it with the green wire so that the induction will be similar to this, and then one with the red wire for here, so those two inductions will be similar. And we'll see, does this one do better or does this one do better? And also, when you're pulling off the radiant and whatnot as well. So why don't we spin this one first, because this is the one that I've gotten spinning before, and then we'll spin this one, and then I'll wrap this video up, and I'm going to do the work that I was talking about. Oh, I like it. I just got to put a racing stripe on it so you can get the RPMs. I like it already. Okay, so here we have one 4-volt battery, and it's hooked up to the bipolar commutator. Here's our code, which we've gone over before, for the bipolar commutation. Here's our reed switch. So I'm going to bring the reed switch in. And away it goes. You see there? I don't want to spin the other way. Let's do it back down here. But you see, it's kind of hard to figure out the angle. You're trying to hold the thing. Let me see if there's a place I can just like... I just want to put it somewhere where I don't need to have my hand on it. And you see, because you're working vertically, I mean, it likes to be like right there, and so I have to hold it there. When I looked at it previously, it was drawn, I would say about 80 milliamps, maybe 90 milliamps, 4 volts. So if it were 100, you'd say 400 milliwatts. So a bit under half a watt. So not really any better than the previous setup. But as I said, you know, this is like the pilot project, and that coil is very thick, and it's also the vast majority of the coil isn't doing anything. So this is actually very promising to me. What I want to do, if I can figure out how to anchor it there, I'm thinking of using like a hands-free thing, but that thing's metal. It might just, oh, that could be bad. What I want to do is draw off some power off the bridge rectifier, and then also if I had my other hand, I could figure out what the RPMs are. Let me see if I can come up with anything. All right, look at this thing go now. It's going way faster. That's what I call high tech. Wow. So let's get an RPM reading, and then I'm gonna load it and see what happens. That thing's spinning. Okay. We're just about at 1,000 RPMs with a single little 4-volt battery there. I bet you it's drawing less than 80 milliamps now. Shoot, I'm going to figure out the amp draw, and then I'm going to load it, and that'll be all I'm going to do with this for now. Okay, I've got an amp meter hooked up. This thing's really sensitive to the positioning of here, of the read in terms of the amp draw. When it was down here, do something. I don't know why it's got problems now. Give me a minute. Okay. 40. This is good. 30 milliamps going down. Now, when you get it out of position, it's hard to tell. This is, I mean, again, because you're working vertically. Yeah, I'm going to leave this one. I don't know what's going on. I'm going to leave this one, but you can see it spins, and there's a lot you could do with it, and I'm going to do more with it. I'll need to figure out how to anchor a reed vertically without using iron, so the iron thing doesn't get pulled in there and kapoof. But it's pretty cool. Now let's do the other one. That I just put that battery there so that the thing didn't wobble back and forth. It's not doing anything. It's all from there. Well, so far the Mara motor is a disaster. Who is that guy? I can't get it to commutate, and I don't know why. It doesn't want to commutate anywhere. What is going on? This makes no sense. I gotta work on this for a while. It should work. I mean, it looks so pretty. It looks like it wants to run, but it doesn't want to commutate. Now, this is neither north nor south, so it's like a big smudge there, but you should be able to put it there or there, and it's still not commutating. It's possible, though unlikely, that the reed switches, they start to stick after a while. I could switch back to the other motor and see if that one's running. I don't know why this doesn't run. Okay, I can sort of see what's going on now, but I can't say I understand it. See what it's doing? And something. Where is it? No, it's easier to... It wants to spin like that. And so I switch those around, and then this side wants to flip up. I see it. I don't understand it. If we look at this, why does this then want to push like that? When this is also there, but now instead of wanting to push out like that, it wants to push like that. Why is that? Why? Is it because there's so much space there? That doesn't make any sense. See, that's what it wants to do. It doesn't want to move the other way. Sorry. I don't understand that. My word. I don't get it. I see that it doesn't work, but I don't know why. Because you can think, all right, now if you flip the magnet like that, so flip that magnet like that, then you're back to there. And if it's behaving like it did before, wouldn't that mean now it wants to flip that way, and this one wants to flip that way, and it would still just do that, except for here it spins like mad. What is different? But I guess, it's important to do, publish negative studies as well. So this is the dud motor. I wish I understood why that didn't work, but I don't understand why it doesn't work. But one thing about the one take home is I prefer having the rotor parallel to the ground, because it makes it much easier for when you want to just put the timing there. So instead of this one, I'm going to have to work with this now, but instead of this being vertical, I'm going to flip the whole thing over sideways. And so it will look like this, except for instead of the magnets being like that, the magnets will be like that. And I think I'll also bring them in so they're flush, because it will make it easier to print one of these. So got to work with this guy, and my next video will be gathering the data, and I want to figure out where's the correct point with the reed switch, and when you're loading it, what will it do? Don't know why it doesn't work, sorry, but hope you enjoyed the video. Very last thing I'll say there is, so many times when I do this, you just get the impression John Bedini already tried it, and if he's not doing it a particular way, you end up like, oh, you know, I guess you can't do that. I mean, you tell me why it doesn't work. I don't know. But there it is, and you know, didn't see one like that in his lab. No, so I thought something you didn't. No, you didn't. So, but we had fun today, and that's important in this crazy world. So we work with this one, we flip it on its side, and we start gathering data. Ciao, y'all. Okay, maybe, just maybe, I get it now. This one does, it would want to flip like that. It does want to flip like that. But because this is north and this is south, the other one wants to flip the other way. So those two cancel out. They still want to flip. And the only thing it can do then is shoot out of there. They both want to flip, but they can't, because that's north and that's south. Here, they both want to flip in the same direction, so this thing just does that every time. But if you had this was north and this was south, those two would cancel out, and what can I do? Oh, it shoots out, and that's what it does there. But you can't make this north and this south, because all that wire is going in the same direction. I'll give it a try just for the heck of it, but I can't see how that would work, because now one side wants to flip out that way and the other side wants to flip out that way. So I think I've flipped out enough on this. In any event, again, have a nice rest of your week, and we'll do some more with these later. So it only ended up being one window motor.